Let's talk about subsets and subspaces. A subset is basically a set with vectors in it, or any collection of vectors, much like a set is any collection of items or numbers. That's what we mainly use in math for sets, and subsets are any collection of vectors. And subspaces are subsets. So every single subspace in the world is a subset. A subspace, however, is a special subset that satisfies those three following conditions. So the first one is that it contains a zero vector. What does this mean? This essentially means we have a resulting, so this vector here, 0, 0, 0, etc. So all its dimensions are 0. This is actually in the subset. So this is what it means. So basically the origin of whatever coordinate plane the vectors are in is in the subset. And the second condition is if vector A and vector B are in the subset, then vector A plus B is in the subset. If vector A is in the subset, that's the third condition. If vector A is in the subset, then S times vector A is in the subset, with S being a scalar number. So S times vector A is basically scaling vector A up or down. So now we have three conditions. Let's just look at a problem. So we want to identify if a given set is a subset, and let me just erase this here. And we'll move down. So this is the first problem. Actually, I'm going to show you the second problem also. So let's work on the first problem. The first problem says, so basically once we are given this subset V, we want to know if this is actually a subspace. Because if it meets the three conditions above, then it's a subspace. So let's check with condition number 1. So we have 0, 0, 0, because all of the vectors in subset V must be in R3. Being in R3 means being in the 3D coordinate system and with real coordinates. So if 0, 0, 0 is in subset V, then 0, 0, 0 has to meet this equation. Apparently it doesn't meet this equation because we have 0 squared minus 4 times 0 equals 0 plus 3, but that's not true because we know that this side is going to be 0 and this side is going to be 3, so these two are not equal. Therefore 0, 0, 0 is not going to be an element of subset V. So therefore this subset V is not a subspace, because the very first condition is that we have to have a zero vector inside subset V. So let's move on to the second problem. The second problem is a little more challenging because, so let's identify the first condition. We want 0, 0, 0 to be an element of vector V. No, wait, not vector V, of subset V. And so this means that this condition has to be met, and we have x is 0 minus 4 times z, which is 0, which is equal to 0, and that is true. So the first condition is true. So 0, 0, 0 is an element of subset V. So we're one step closer to proving whether or not V is a subspace. So therefore, let's prove the second step. So the second condition basically says if I have vectors x1, y1, z1 that are inside, if I have these vectors that are inside, so this vector is an element of subset V, and the second vector x2, y2, z2 is also in the subset V. So this means that, so before we proceed, we want to state out what we know. So this essentially means that x1 minus 4 times z1 is equal to 0, because that's the whole condition for being in the subset, right? And x2 minus 4z2 is equal to 0. So the second condition states that if I sum the two vectors together, then I have x1 plus x2, y1 plus y2, z1 plus z2. So this has to be in subset V. So this has to be in subset V. And so this means that if this were in subset V, then x1 plus x2 minus 4z1 plus z2 has to be equal to 0. But is that true? Let's just find out. So if we expand the brackets, we have x1 plus x2 minus 4z1 minus 4z2, and that's supposed to be equal to 0. So let's evaluate this. However, we know that x1 minus 4z1 is equal to 0, as I've stated above, because the two vectors are part of the subset, and x2 minus 4z2 is also 0. So this means that we have 0 plus 0, which is essentially 0. So yes, if x1, y1, z1 is in subset V, and x2, y2, z2 is in subset V, then x1 plus x2, y1 plus y2, and z1 plus z2, this vector here, is also in subset V. So this is great. We've met the second condition. So let's prove the last condition to see if it's true. So the last condition basically means so the third condition basically says given x1, y1, z1 is part of, so this is going to be part of subset V, and x2, y2, z2 is in vector V, is in subset V, then never mind. So given that x1, y1, z1 is in subset V, any scalar, and we know that s is a real number, then any scalar, so any scalar times x1, y1, z1 has to be in subset V. So if this condition is true, then we're done. Like, the answer is going to be yes, because so V is a subspace. So what does this actually give us on the left hand side? So this is actually equal to sx1, sy1, sz1, right? So this vector has to be in subset V. So how do we prove this? Now, given that x1, y1, z1, this vector here is in subset V, we know that therefore x1 minus 4z1 is equal to 0. Because, let me check. Because above here it says x minus 4z is 0. So x1 minus 4z1 is 0. So this means that if this were to be in vector V, sx1 minus 4sz1 has to be equal to 0. So this is true. Well, yes it is, because if we factor out s and we have x1 minus 4z1, we know that x1 minus 4z1 is 0. Basically s times 0, so this is s times 0, and that is just 0. So therefore, the third condition is also met. So this is just great. Our three conditions are met, and therefore, so we have a conclusion. So we come to a conclusion that V is a subspace. So I hope this video allows you to understand more about subsets and subspaces, and how we can identify whether or not a subset is a subspace. So thanks for watching. Bye.